Alright, here we're looking at standard MM2A2E. We're going to use exponential functions to model real-world phenomena. Now, when I looked at this problem, you're not going to have to come up with average annual percent increase yet. So I'm going to give you that. That should be 2.13%. And so you're not going to have to use this number. You'll use this as your percent increase. So 2.13% is the average annual increase. Also, I'm going to have to give you a little bit more information. Our population the first year in 1990 is going to be 12,941,197. So this right here is our population the first year. So this is the information we're going to use to come up with our function. So our function, so again, this is how you'd be given this information. You're not going to have to go through this process yet. We'll deal with that later in class. Alright, so this was our starting population. Okay, and then our population's increasing by 2.13% every year. And so what we'll end up doing is having 1 plus, now remember we're going to convert this to a decimal, 0.0213. So this would be our growth factor. Now you don't have to list that, but that's how much it's growing. So that's going to be our growth factor, and then we'll use t as our variable for the number of years. So let's clean this up just a little bit. So for number 14, this is what I'm looking for. So how we can write it so that we can use it. Remember, when it's growing, this number is going to be bigger than 1. If it's decreasing or decaying, it would be less than 1. Okay, so for this one, that's how we would do this. So this population in 1990 was this, and then this is our growth factor, and we can figure out how much we have. Now, for this, from 1990 to 2000, which was given, you could put in 10 for this, and you should be able to come up with the number that was originally given in the problem of the 15,982,378. Okay, but they're asking, what about in 2010? Well, how many years has that been? Well, from 1990 to 2010, that's been 20 years, so t would be 20 here. So we'll plug that in. And that should give us an estimate of what the population is. Alright, this is from page 122 in your book. Question 16 and 17. What's the population? Now, they gave you the model here. Okay, now we've been dealing with it with f of x or y, but they gave you an equation to model population growth here. Now, if we want 1990, okay, what was the population in 1990? Okay, you put in, remember we put in 0 for t because that's the first year. We wouldn't say 91 would be the first year out. So you put in 0. So our population here is just 29,008,016,591. So it's almost like a trick question, but you just put in 0 for t, okay, and this becomes 1, and then it'd be that for that. Now the growth factor is simply this. Now annual percent increase would be your decimal part of this, just in percentage. So we are basically end up subtracting out 1, but the percent increase would be, you could subtract 1. So it'd be 1 minus, well, let's subtract 1 the other way. 1.0128 minus 1, so we get 0.0128, and then just convert that to a percentage. It'd be 0.128%. Okay, now on the quiz, you're not going to have to do that. In the quiz, you're going to mainly be coming up with this type of model and then using it. Alright, on page 127 are more like the problems you'll see. You'll be given information like this. Now it'll be either growth or a decay. Now this particular problem is a decay, and let's see why. A manufacturer of a company purchases a piece of equipment for its assembly line. This is the cost. So that would be what we started out with. The value of the equipment depreciates. Depreciation, it would be a decay. So it's decaying. Okay, and so at a rate of 1.8% each year. It says write an exponential decay model. Now this right here is what you need to be able to do. So we will say f of x is equal to the original amount, 17500. Okay, then 1, now it's a decay, so we're going to subtract our decimal here. So it's going to end up being, move it 2 places over, so we get 0.18. And then we'll put t as our variable. Now I'm going to come down here and clean that up a little bit. So for 18, our model would look like this. F of x is equal to 17,005. Yeah, I left off a 0 here. Alright, and then we're going to go ahead and subtract the 1 from the 18. So we end up with 0.82 to the t power. Now this would be our decay factor, the 0.82. Now then we go to part 19. It says what is the value of the equipment after 10 years. This is where we plug in 10 for t. Alright, and so now here's what we get after 10 years. It's only worth $24,000 roughly. Now it's money, so, and we would use this on our taxes. So we're for this company. So we'll put in a decimal place, but it should be $24,053.41 is what the value of the equipment is after 10 years. We're not going to graph it right now, but we could look at it later. Now let's look at 21. It says 5 years ago you purchased a riding lawnmower for $16,000. Recently you sold the mower for $525. Assuming that the value of the mower decays exponentially with time, write an exponential decay model that gives the value in dollars as a function of time for the mower. Alright, so let's look at this. So that's the value of the mower. Okay, we originally paid $1,600. Okay, we sold it for $525, so we could put $525 here. Okay, and we're trying to figure out what this part is. Okay, and then T is the number of years. Alright, and so we set it up this way. Now we're trying to find what the decay factor is, so we're kind of working backwards. Now T, we said we sold it after 5 years, so we can replace this with 5. Alright, and so to solve this, what we do is just divide both sides by 1,600. Alright, and then once you divide that, you get 0.328125. That's probably been a while since you've done this, but to undo something to the fifth root, okay, I'll just take, something to the fifth power, I'll take the fifth root. Your calculator should be able to do this, but if you do the fifth root of this, you end up with x is equal to 0.8. Okay, and so that would be our decay factor. So to come up with a formula or a model for this, we just write V is equal to $1,600 times 0.8 to the t power. So however many years we put in that would give us the value of the lawnmower. I'm going to finish the rest of it in the second video.